Adiabatic process. In first law, the first term that we normally use is heat transfer. Remember, it's heat transfer. It is not the total amount of heat. The process that we study, in that process, the amount of transfer of heat that is represented by this first term. And a process in which this transfer is not taking place will be said as adiabatic process. If there is no heat transfer, that means the container that is used here is perfectly insulated, only then it is going to obstruct the transfer of heat completely. Or else you have another option also. If you practice or you allow the process to take place suddenly you press the piston, in that case the heat will not be having sufficient time to leak through. So you are having two options only. One is that the container should be perfectly insulated, and second one is that the process should be very fast, rapid, very sudden process. So out of these two conditions, one must be adopted there definitely. You see, then that is adiabatic process, and you put this equal to 0, you are going to get du plus dw. Du is minus dw. Change in internal energy, that will be opposite in nature to work done. Suppose the expansion takes place. Remember, when we are talking about expansion, it is going to be sudden. For example, tube, tires tube in the vehicles that we use, tube full of gas, if that is suddenly burst, that means the gas that was at high pressure inside will expand immediately very fast because of the vast space, the difference there. In that case, expansion will take place, volume will increase, so work done will be positive. And when the work done is positive, you see, it is going to be negative. Change in internal energy is negative. What does it mean? It simply means internal energy is decreasing, and that way temperature is also decreasing. So you could say directly, wherever sudden expansion takes place, it is followed by cooling, as it happens in the case of refrigerator. When the gas from the compressor goes out, this suddenly expands, and when it expands, cooling takes place. That is our ambition to use refrigerator. Only the cooling is the thing that we strive for while getting refrigerator. Then, as far as the representation is concerned, you see isothermal process, adiabatic process. For the same expansion under the iso, or you could say identical parameters, if you are allowing same expansion, that is from V1 to V2, once isothermally and the other time adiabatically, you will find that area enclosed with the isothermal process is greater. You see here, isothermal process will enclose greater area, and that way you could say the work done is greater in case of isothermal process. Adiabatic process will be having greater slope, but the area enclosed will be obviously less, so it will be involving less amount of work. If you say isochoric process, isochoric means, you see, isochoric volume is constant, so no question arises for any area enclosed. In isochoric process, there is no work at all. Isobaric, you see, out of these four processes, if you compare the work in isobaric process, the work is going to be the maximum because it will involve maximum area. If I could draw over here, this is the case. This is isothermal, this is adiabatic, this is isobaric, this is isochoric. You could see the area involved is maximum for isothermal only. That's why I said out of these processes, three, the work done will be maximum in isothermal. And if you talk about all the four processes, the work done is maximum in isobaric process. And then as far as the slope is concerned, the ratio of the two slope of adiabatic, that the slope of isothermal. This ratio comes out to be gamma, which is also the ratio of Cp upon Cv. One more thing you have to remember, that if you consider the modulus of elasticity in isothermal process, you would call isothermal modulus, and in adiabatic process, you will call it adiabatic modulus, represented by Et and Eq. Their ratio is also going to be the same, that is gamma, means the two modulus will be having a ratio of gamma itself. This ratio is known as adiabatic exponent. Other relations that we use for adiabatic process are given over here. Pv to the power gamma constant, Tv power gamma minus 1 constant, and then T to the power gamma upon P1 minus gamma, that is constant. The work done in adiabatic processes, one formula we can have mu Cv delta T. This is work done. The other is Pf Vf minus Pi Vi upon, this is given 1 minus gamma, and Pv is also equal to nRT, so that way you could also say mu r Tf minus Ti upon 1 minus gamma. So you have the option of using any one of these three relations for work done in adiabatic process. All the points that's given on the page have been